Today I want to talk about phase shift and target identification in metal detecting. Concepts that are hard to understand for the beginner. Phase shift and target identification, or TID, are terms you come across early in your exploration of metal detecting technology. Here I want to explain these terms, what they mean, and how phase shift is related to target identification. The basics of electricity tell us that when running a current through a wire, it creates an electromagnetic field around that wire. If you move another wire through that field, it induces current into that second wire. That effect is called electromagnetic force, or EMF. Now, it doesn't matter if the wire moves through a stationary field or an alternating field moves through a stationary wire. The generation of EMF works the same in both cases. A detector runs a radio frequency current anywhere from 5 kilohertz to 20 kilohertz through a coil. This creates a moving field that expands and contracts many times each second. This is a moving field. A coin in the ground is like a tiny, maybe half-inch piece of wire. The moving field from the coil induces a very small EMF in the coin, called an eddy current. Now here's the trick. The physics of that current in the coin are such that it pushes back in the opposite direction against the current in the detector coil. This pushback, or echo, slows the current in the coil, but it has no effect on the voltage. The result is that the current in the detector coil becomes out of step with the voltage. This is called phase shift in electrical jargon. It means the current waveform lags behind the voltage waveform. Phase shift from a coin in the ground. A highly conductive target such as a silver dollar will generate a large phase shift in the detector coil. A zinc penny will cause a smaller shift, and a rusty nail even less of a shift. The pushback from the target also explains why you get mixed signals from an asymmetrical target. A long nail scanned in one direction will produce a different phase shift than if scanned at 90 degrees from the original swing. These changes in the current, voltage, phase shift are exceedingly small, so it takes a highly refined signal processing circuit to detect the differences. For the less expensive detectors, the phase shift scale is broken into segments or categories. In the Garrett Ace 250, for example, there are 12 bands or notches that span the entire phase shift scale. Around the middle of that scale is a notch for nickels. At the high end, a notch that includes $1 coins and other coins like quarters. In a more expensive detector, the phase shift scale is more exquisitely defined into many more specific readings called visual identification numbers, or VID numbers. The engineering for this finer performance is what makes the detector more costly. The payoff, however, is that you have much more specific target identification. This allows you to distinguish between a zinc penny and a copper penny, or between a silver dime and a clad dime. The VID scale numbers from any one manufacturer are generally different from other machines. Whichever detector you use, you soon become very familiar with the numbers corresponding to specific coins, like a 28 is going to be a quarter on one machine, and a 20 is going to be a penny, and an 18 is going to be a zinc penny, etc. You see, after using your detector for a while, you learn those things. I hope this answers your questions. Good luck. Happy hunting.